This video is for factoring by grouping. So this is section 4.4. And the second factoring strategy is factoring by grouping. So you use factoring by grouping when your polynomial has 4 terms. If you look at this examples below, all the polynomials have 4 terms. And there is no greatest common factor for all 4 terms. But there are greatest common factor for pairs. So what we're going to do is we're going to split this problem in half and do a greatest common factor for these pairs. So this is how it works. If you look at A, there's no greatest common factor for all of these terms. This has a coefficient of 1, and this term doesn't have an x. So there isn't a greatest common factor for all 4 terms. However, if I think about splitting this problem in half, if I look at these first 2 terms, there is a greatest common factor here. It's x squared, right? Because they both have x's. This term has 2 x's. This term has 3. But let's see how we would get to that greatest common factor. So if you're going to do your trees like we've been doing, the only number we have here is a 1, and we have 3 x's. And if I were going to tree the 4, I would tree it into 2 and 2, and we would have 2 x's. So if you think about common numbers that we would circle, there aren't any. But if you think about common x's, they both have 2 x's. So that's where I got that greatest common factor of x squared. So remember, the greatest common factor goes on the outside, and the leftovers, what we didn't circle, go on the inside. So here, what didn't we circle was a 1 and an x, so 1 times x is x. And here, what we didn't circle is a 2 and a 2. 2 times 2 is 4, and everything's positive. All right, now we're going to do a greatest common factor factoring over here for these last 2 terms. So we're taking this big problem with 4 terms and splitting it in half. So if we tree 3, we get 1 and 3, and we have 1x. If we tree 12, we have 2 and 6. And 6 we can tree again into 2 and 3. Put an x through that because we treed it further. And no x. So when you look at just over here, the right side of my squiggly line, what we have in common, well, it's just a 3. So, and it's a positive 3. So we're going to have plus 3. Greatest common factor goes on the outside. And our leftovers here will be an x. And our leftover here is a 2 and another 2. 2 times 2 is 4, all positive. Now this is where, when we did one of these in class, we talked about, hey, I have these matching factors. Remember? When you're doing factoring by grouping, you should end up at this step with these matching factors, x plus 4, x plus 4. If you don't end up with those, then you mess something up. You should go back and check your factoring up here. So you want to take out that common factor of x plus 4. And then what you're going to multiply that by is what I call now the leftovers. What's left over? Well, over here, what's left over is x squared. It's just like the leftovers we did up here. And over here, what's left over is plus 3. Okay, so the common factor here is x plus 4, and the leftovers are x squared plus 3. So that is that factored. Let's take a look at another one. This one's got some negatives, so we have to be careful with the negative. So again, draw your squiggly line and split this in half. We're going to factor greatest common factor out of these 2 terms, the front half, and a greatest common factor out of the back half. So let's start by doing our tree. 2 trees into 1 times 2, and I have 3 x's. 4 trees into 2 times 2, and I have 2 x's. So what do we have in common? They both have a 2, and they both have 2 x's. So remember, we circle what's common. So 2 x squared is common. X times x is x squared. So what's common goes out front, and what's left over goes inside. What's left over here? 1 times x, which is just x. And the only thing we didn't circle over here is 2. So that's going to be plus 2. Now over here, we're going to do a tree. And remember, we start our tree with a -1 and 5. 5, you can't tree any further, so that's an x. We're going to start this with -1 and 10. And 10, we're going to tree again into 5 times 2. So cross that out because we treat it further. So what's common? -1 is common. 5 is common. And that is it. And when you have a negative here, you're always going to take out a negative greatest common factor. So this negative will always carry down, which it did in this case, because what's common is -1 times 5, which is -5. That goes on the outside. What's left over is x and +2. And then remember, if we did it right, these two factors should match, and they do, so we did it right. So the common factor now is x plus 2, and the leftovers are 2x squared minus 5. So times 2x squared minus 5. So that is fully factored. All right, let's do a couple more here. Part C here. Remember, 4 terms, no greatest common factor. Split it in half. Do greatest common factor up front here. So let's tree our 3 into 1 times 3 and 3 x's. Draw my line here. X squared, but I have a negative in front of there, so be careful. This is going to be -1, and then I have 2 x's. Okay, so what is common? Just x's, and 2 of them. So common factor, which is x times x, goes out front. Leftovers, or what we didn't circle, goes inside. So up here, what we didn't circle is a 1 and a 3 and an x. 1 times 3 times x is 3x. Over here, what we didn't circle is a -1. So -1. Okay, now let's do the same thing over here. Ooh, 21. That might be a big tree. Let's see. It's 7 times 3. It's not so big because 7 and 3 are both prime numbers, so I can't tree that any further, but I do want to include my x. And then a -7, -1 times 7, and 7 is prime, so that tree is done. So what is common? Looks like just the 7. So what is common is +7, so I'm going to write +7. Common factor goes on the outside. What's left over here? 3 and x. 3 times x, that's 3x. And what's left over here? -1. And look, these two factors match again. So now our common factor is 3x minus 1. And the leftovers are x squared plus 7. There we go. Okay, do one more, I think, in this video. And then we'll do one more. Again, 4 terms, split it in half. So don't skip that step with that squiggly line. That reminds you, greatest common factor here, greatest common factor here. So if I tree this, well, there's no number, so we'll put the 1 and then 3 x's. And if I tree -10, I'm going to do -1 and 10, and then 2 and 5, and 2 x's. So it doesn't look like there's any numbers in common. The only thing in common is 2 x's. So x squared is common. That comes out front, and my leftovers here is a 1 and an x. 1 times x is x. And the leftovers here, oh, let's get rid of that 10 because I treed that further. So the leftovers here are negative 1 times 2 times 5. That's negative 10. Okay, let's come up here. So let's tree this. I'm going to tree this into negative 1 times 6 first, and then 6 into 2 times 3, and I have an x. And 60. Ooh, that could be a big one. First thing that pops into my head is 6 times 10. 6 trees to 2 times 3. 10 trees to 2 times 5. So cross off the 6, cross off the 10, because you treed those further. Okay, I'm going to cover this up. A lot of numbers going on here. So I just want to look at what's common here and here. Well, right away, that 2 and 3 are jumping out at me, so that's common. And I think that's it. I got a 2 and a 5, and a negative 1 and an x. So the 2 and 3 are all that's common here. Now, I'm thinking 2 times 3 is positive 6, but remember I said if you have a negative here, you need to take that negative down, and your greatest common factor will always be negative. So I'm going to circle that negative 1 because I know I'm going to need this greatest common factor to not just be 6, but that negative 1 needs to carry down. So my greatest common factor is actually negative 6. What I have left here is an x. And what I have left here is 2 times 5, a 10. So plus 10. Uh-oh. What happened? These should match, and they are not. And it's probably having to do with this negative. So negative 6x, yes. Oh, I actually need a negative here. Negative. I still need this to be negative. But this, I need to be negative also, because when I multiply, if I multiply negative 6 times x, I get negative 6x. And if I multiply negative 6 times negative 10, I get positive 60. So that's what I need here. So you have to, when you have negatives, you have to be careful and you have to do that check. Do the distributive here and make sure you ended up with what you had up here. And I also know these two factors need to match. So now my common factor is x minus 10, and my leftovers are x squared minus 6. So that one was a little weird. Let's try one more, since that one was a little weird. This one's got all pluses, so it should not be too bad. So, split it in half. Ooh, it's got a lot of x's. That's okay. So 10 is going to be 2 and 5 and 4 x's. 8 is going to be 2 and 4. And then 4, I can tree one more time, so cross that off, and 3 x's. Okay, I know we're going to have some x's in common, but I also notice we have a 2 and a 2 in common. And then 3 x's. So that's all of the x's here. So what comes out front, what's my greatest common factor, is 2x to the third. X times x is x to the third. And what is left over is 5 times x. 5 and x are not circled. And what's not circled over here is 2 and 2. So that's just 4. 2 times 2 is 4. So let's do a quick check here. 2 times 5 is 10. Yep, that's what I started with. X to the third times x to the 1 is x to the fourth. Yep. 2 times 4 is 8. Yes. Times x to the third. Okay, that looks good. All right, let's go over here. Let's do a tree on our 15. That's just 3 times 5 with 1x. Let's do a tree on our 12. 3 times 4. But 4, I can tree one further. Cross off that 4 because I treat it one further. And no x here. So what's common? A 3. And that is it. Remember, I'm just looking here. 3 is common. This has an x, no x is here. So common factor is 3, and it's positive. So we're going to do plus 3 is going to go on the outside. What's left over here? 5 times x, 5x. What's left over here? 2 times 2, 4. So this looks good. 5x plus 4, 5x plus 4. So my common factor is 5x plus 4. My leftovers, 2x to the third plus 3. 2x to the third plus 3. Okay, that is it for factoring by grouping.